interviewers watch Dagger in you. So if you have Dagger in your skill set, then you have +1 with your resume. So what is dependency injection? Can anyone try to explain dependency injection? Please don't react this way, right? So, okay, let me start with dependency. So, dependency is typically, if we look at the picture, we have black box, okay? This black box is dependent on 3 other colors, red, green and blue. So, it can be said that black box is dependent on those 3 objects. This implies that dependency is simply nothing but an object that can be injected, right? And what is injection? No, not this one. So injection means to inject something, right? And what is dependency injection if we combine both of them? So if we consider this picture, dependency injection means if you consider injection, charging now. So if we consider dependency injection, injection means passing of one or more objects to dependent class, right? Dependency injection, we can say, is a form of inversion of control. If you have heard this term, inversion of control, which means that any class should be getting its dependency from outside, and class should be getting its dependency from a configuration class, and it should not be initializing any object from within the same class or same method. So what does that mean and what it can result into? That we can say that we can write testable code. Previously Kapil explained that how we can write test cases, right? We can decouple classes and its dependency, and we can design a maintainable and reusable structure. So yeah, it is pretty interesting, and let's dive into DY. So what is reflection? So not this reflection. So diffraction, we can say that it enables the ability to examine, and moreover it can modify the behavior of runtime behavior. And the reflection API was introduced in 1.5. Drawbacks were typically it had performance overheads because it has to detect some class on the runtime, and you have to call methods and all. Exposure of internals, you have to like, even if your field is private, you can read its properties and you can access its values. Example of reflection API, we have been using reflection API since long, but I hope if all of you know what is reflection. Javalang, javalang.reflect, these both packages contains classes from reflection API. Class is a class. If you know this class, anyone knows? Okay. For logging purpose, we might be using this main activity .class .get simple name or get canonical name or something. So this is the reflection. So we might want to see who used this reflection API. So Dagger 1, typically Square Inc., they wrote this Dagger 1, and it was purely based on reflection. So typically we don't need to just inject just a single dependency. We can do it normally with new keyword over there. Means you will be having multiple dependencies if you want to go for Dagger, right? And more dependency injection means you got more performance overheads. And yes, one more thing, that dependency injection, like when you use reflection, error tracing was highly untraceable. Like when your app gets crashed, you won't be able to judge, or trace log was so typical to understand that you won't be able to make out why this crash was happening. Sometimes, like this is the scenario what happens. So thanks to Google, they forked this Square Dagger, and they revamped the whole underlying architecture, and Dagger 2 was born. So let's get started with Dagger 2. So what is annotation? We have heard a lot about that this annotation @inject or @override also we use in onCreate. Besides bundle, you will see that @override, right? So what is annotation? Okay. So annotation is a class of metadata, and this was also introduced in Java 1.5 itself, and it can be associated in over class, over methods, over fields, or over another annotation itself. Those metadata were used with Dagger 1. What Dagger 1 was doing was it was using the same metadata, and it was providing the runtime behavior. But what if the same metadata can be accessed at compile time? And this is what actually annotation processors do. Have you ever worked or have you ever heard this word annotation processor? Great. So I see some guys, they have been using annotation processors. Even you are using, but you don't know that you are using this annotation processor. Annotation processors are nothing but they are code generators. Say simply write code on behalf of you, and yeah, obviously these annotation processes are compile time process, so there is no performance over it, and you can use it freely and without bothering any thing of performance. So even you can also create annotations, and I have provided the links. Once I have shared my presentation, you would be able to go to link, and if you want to try with annotations yourself. So how Dagger 2 differs from Dagger 1? Dagger 1 was purely based on annotation, reflection, but 2 is purely based on annotation processors. Which client is dependent on which object is resolved on compile time. So we have no performance overheads at all, and hence Dagger 2 is free from performance overheads, and Dagger 2 errors are traceable. Like on the compilation time only, you will be able to identify that somewhere some dependencies are not being resolved. So that is the big plus for this Dagger 2. So how many modes of dependency injection available? JSR 330, Java specification request. It's a set of protocol defined for Java, and annotation means there they have defined how to use annotations, like how annotation should be implemented and all. So there are 3 types of DIs we typically do in any dependency injection. One is constructor injection. You inject any dependency into a constructor. Second is field injection, but for field injection, your field should be non-private. It should be anything, but it should not be private. And third one is method injection. You know some of the annotation processors. Butterknife is an annotation processor. We say that dependency is dynamically coming into it, but it is not dynamically. It is already statically. It is already written in your code. It's just that you are not writing that code, and annotation processors are writing that lines on behalf of you. And even Room is also annotation processor. Other annotation processors, retrofit, you write @post and all. Everywhere you see annotation processors, and it's just it. So let's go with Dagger 2. So this is my objective. I have random user API. It's a kind of API available that if you post a get method, it will return list of users. So I'll be showing list of users, and let's see. So this is my typical random user application class. Is it readable from the last? If you can manage to come forward, because I see empty seats in between. So if you don't want to come forward, then it's okay. You need to make it fast because I don't have much time to wait. So I took screenshots because code, all of them, it was difficult to put it here in slides. Okay, so I have normal application which I have written very normally, no Dagger, nothing, and I'll be converting the current application into Dagger form. how I'll be doing it is, what I did is currently I'm displaying the random user application, my application class, in which typically I have written all the code. I have JSON builder, Timber I have planted, then HTTP logging, OKHTTP client, retrofit and all. And I have one getter method also, which will be returning some random user service and all. So I'm not happy. First is because my code is so typically written that I need to initialize each and every dependency in the same order. I cannot rearrange the code, like I cannot initialize OKHTTP above or say JSON builder later, so it won't actually compile my code. Second is code is very clumsy, as I said. Third is code is not test friendly. Kapil already explained that how to write test cases and all. So this, my current application, when I say it is not a test friendly. So how to make it? Picasso is breaking my rule. So I had an adapter for to display list. So typically I have written this code to show images and all. Picasso, how Picasso is breaking my rule? Picasso with image and load into and into image, when that all typical code we write. Thing is, Picasso is not coming from outside, and earlier I explained the inversion of control rule. It says that any dependency should be coming from outside, and it should not, and we should not be creating any objects from within the class. So Picasso is breaking my rule over here. So what is my next step? I need to look on these two issues, that clumsy initializations, and I need to write more testable cases. First, and this is what I have observed, actually I just learned Dagger in just one night. So this is steps I followed, that identify classes that are secretly dependent on objects. Like I showed Picasso, so it is secretly hiding in my method. Next is provide dependency through constructor arguments. So I'll be passing Picasso as my adapter's constructor argument. Next, do necessary object creation at one level. You can define at application level. Any object that you need to initialize should be declared at application level. So next, this is now I have refactored that I have brought where is my Picasso code is over here. So I brought that Picasso code from adapter to over here, and rest of the code is same. I have written my context, I have planted Timber, HTTP logging interceptor, file for caching, cache I have implemented, OKHTTP downloader. Okay, one more thing I have configured is from the previous one, that Picasso I'll be using downloader, OKHTTP downloader, and JSON I have created, and so this is the whole graph actually, and this is the step. This is called dependency graph. What we did in those steps, moving code from hidden dependencies to bringing it to one level, and I just arrange them and I just build this graph, that my file cache needs context, cache needs file, OKHTTP needs cache, OKHTTP downloader needs OKHTTP client, my Picasso needs downloader and all. So this is, you are creating a dependency graph. From a dependency graph you would be able to clearly create components and modules and all. I'll talk about that. So first thing you need to do is, obviously you won't be able to write without this. Annotations with Dagger 2, what are the annotations available? It's modules and provide. Modules typically are classes, and within those classes we'll have some methods which will be returning the dependencies what we want. @inject will actually inject the dependency into whatever field or in a constructor you are writing the inject. And @component, they enable the selected components and they provide the actual dependencies from there. So let's start with component. Component, what is component? Component is an interface. Okay, remember my points and I will make sure that you know Dagger very well. Component would be an interface, okay, and it will be having no implementation. Obviously it is an interface, right? So there will be methods that will be returning those dependencies, but without implementation. So best practices say that we should only expose top level dependencies. Top level means, so this is my hierarchy. Top level from this graph, we can say the bottom ones. Okay, we'll be exposing these dependencies. So we should expose only top level dependencies, and internal dependencies will remain under the hood. So I created a random user application component. Is this visible from back? Right. So random user application component I have created two methods, Picasso, which will be returning Picasso, and random user service. So what this tells that Dagger, that this is not an ordinary interface. This is a Dagger component, and Dagger will generate a subclass of this component. And next, so this is what we have done till now. We have created a component and we have written two methods in it. But how will component know that how to bring those dependencies of Picasso and random user service? So this is where module comes into picture. Modules are as I said earlier, that they are classes. They provide the dependencies. How they provide, we'll see that. And I created three other modules, and I'll show you how. So first module I created was Picasso module. I have annotated with @module. I have created two methods in it, OKHTTP downloader and Picasso. Yeah, and I have annotated with @provides. Second module I have created is OKHTTP module, that OKHTTP client, file, cache, HTTP interceptor and all. Third module I created is random user service module. It will be providing random user service object. So by now we have created three modules and one component, okay, with their relevant methods in it. We are all set, but Picasso and OKHTTP module are incomplete without context. How? My OKHTTP module, it requires file. Its file dependency requires context, and Picasso module also needs context, and OKHTTP client as well. So how this will work? Managing external dependencies. How external dependencies means, I mean to say that dependencies on which our graph itself is dependent on. Means I can create objects of file, cache, OKHTTP interceptor and all. Can I create object of activity with new or context or service? No. Anyone lucky creating objects with new? Okay. So we never create objects with new keyword for these components, right? So what I did is I created a context module, and I have a method which will return context. I also have a constructor which will be initializing this context module class. So by now we have fourth module, context, added to our current scenario. But how will we inject context into this? So we have includes attribute, like we have other modules which require context. So how do I tell other modules that we have one more module which will be returning context? So we have, with includes attribute we can do this. So at module I can write includes, I can write OKHTTP module, and with OKHTTP module I need a context module. Didn't anyone have a question that why didn't I include context module over Picasso also? Because Picasso also was requiring context, and I just included OKHTTP client module. So this is how Dagger 2 is smart. Dagger 2's this module, OKHTTP client module, is already having context module. So whenever I include this module into another modules, those dependencies are already resolved, because I have already added once over here. So I don't need to include it everywhere. So by now all our modules are connected, okay, and we are now just remaining to tell our component that which modules you need to depend on. So with component we have modules attribute, and this is how we say connect modules to component. We have modules attribute and we can specify just 2 modules. We don't need to, again I am repeating, we don't need to include all the modules. If we include just these 2 modules, means all the dependencies will be available from passing with just 2 modules. So this is what we have done till now, and now hit Gradle. Typically this is very boring task. Actually I am facing typical issues with this. And if you are lucky, random user application component builder, this is one class that will be generated when you hit Gradle, and the magic happens now is that I have written this code and all of the code is gone. What statement I have written is random user application component. So when I hit Gradle, I create Dagger creates this component class, and with builder pattern. I hope you are aware of builder pattern, design patterns. Yes. So with builder pattern they create such class, and I can now write random user application component dot get random user service. It will be providing random user service, and with get Picasso it will be providing get Picasso. And I have 2 other methods that it will be returning get random user service over here. So still there is one problem. Every time I call component.build, it creates new instance. This is how Dagger is actually built. It is like, it's not a bug with Dagger, but it creates new instance. So one would wonder that why Dagger doesn't know that I just need Picasso instance just once. It should not be created multiple times. Dagger knows it, but we need to tell it. How? Limit the instances by scopes. So we have scope kind of concept with Dagger that you will be providing with component and modules as well. So what are scopes? Scope annotation informs Dagger to share same instance every time component.build will be called. So it will make dependencies work as singleton for that particular component. And this is how we create a scope. At the rate scope retention, if you want to write, anyone knows retention? Yes. Yes, is right. In our case, we will be talking about annotations. How long annotations we need to keep this annotation in JVM. So this is what we write in retention policies. So we have retention and at the rate interface. This is actually an interface. Have you ever tried with writing at the rate interface? Okay. So we have created a scope by writing this much code, and how we'll apply is, first of all we'll apply at component level. We have written random user application scope at the top, and we have components that all code is same. We just added one annotation, random user application scope, and the same scope will be providing to all those dependencies which you need to be singleton for that particular component. So I have this I have provided over here, and I have provided over here, and I have provided over here. So what does this mean? This means that this scope I have given, and beyond this scope no one can create object of this, and it will be singleton. So typically we need 2 types of context. One for say doing other stuff like shared preferences and all, and other context we need to show update UI or something. On that time we need activity context. So problem here is Dagger doesn't differentiate between which type of context it is. Is it an activity context or an application context or what? So we need to tell Dagger that for this modules or say this dependencies you should be using activity context, and this modules and dependencies, you will be using activity context. So how do we create this? So first of all, we have to create an activity module, and we'll be creating a final field context now. We have constructor and we have a field that will be returning context. Obviously we have the scope itself, so we have to limit the scope also. So to fulfill our purpose, we have named annotations. What does name annotations do? They typically differentiate between two dependencies. So this is how we annotate. We have @name, we provide this string application context. We have name provide activity context. So I have two modules. These two modules are providing two different contexts, and I have differentiated them with @name activity. And this is how I'll be using it. Say if I want to use application context in HTTP for file caching, I need application context. So I have provided @name application context over here. So this dependency here, whatever will be injected, it will be application context and not activity context. So same is with Picasso module. We don't need to maintain those strings, right? You would maintain in some static classes or say static fields, but still you need to do this. So alternative to named annotations we have is qualifiers. What qualifiers do is you declare a qualifier this way, like @qualifier you provide, @interface, application context, and that all. So with this qualifier I am telling that this is application context, and with same qualifier we'll be creating for activity, and we'll be creating this is activity context. And how we'll be producing how I'll be signifying this is from here. OK HTTP module, I'll be specifying that this is application context, and same with Picasso. So by now we are done with this. Next, excuse me, application level dependencies we have streamlined over there. But what about activity level dependencies? Like activity life cycles are different from application life cycle. It has some on create and on destroy, and I don't know what is between going on. So and activity lifecycle has a bunch of methods over there. So how do you maintain the integrity between life cycles of an object? So this is where sub-components come into picture. Like I need to create multiple components, and let's see how. So creating multiple components. So when you inject dependencies into clients who lifecycle methods are different from where it is coming, so you should be creating a separate component for that, separate component and modules for that that client. So firstly, let's have activity level scope. So first of all, we'll be creating an activity level scope. It is the same process at the scope, at the interface, and we have created the scope. Then dependency attributes. What does dependency attribute do is, now I have created activity level component. I need to create a component at activity level. So I need to tell that component that if you are looking for any dependency, then you have some other component as well, and you are passing it over here with dependencies attribute. That you have application level dependency, from there you can get your and resolve your dependencies. So I have created an interface main activity component, and I have written two objects, random user adapter and random user service. Okay, so I was having random user adapter also with new objects kind of, but I just moved with dependency injection. Next, so I have created an activity component, and now which is connected with application level component as well. So we have scope main activity module. So after I creating component, I'll be creating module. So I have main activity module, constructor I have field with that, and main activity scope is applied to it, means it will be created and maintained within that scope. And random user application also, random user adapter, I have created object over here, and main activity is passing, and Picasso I'll be resolving from there. So by now we have two different scopes, two different levels of dependencies. Both components are connected, modules are connected, they can communicate with each other, they can resolve dependencies with this much code, right? So let's check the change, what we are changing in activity in an application class. So in application class, I was having, I don't think there is any change with application class. Random user application component dot builder, and we have context initialized with that. Context I will be initializing this way, and I have a getter method which will be returning application component. What happened in activity? I initialized this main component this way. As I said, builder pattern. For components they will be generating builder pattern. So I have main activity module, I have initialized module over here, and I have initialized application module as well, application component as well, because my main activity module also needs dependencies from application level modules. So I have connected with them, and we have some initializations over here. Random user main activity component dot random user service, and it will be providing random user service and adapters, and rest of the code is same like we write in our normal applications. So we have a call, retrofit call, and I have enqueued, and I have just set the results into adapter. So by now our code base is much more cleaner, right? But still we can go more with it. I have this class, okay, but what if I have 50 dependencies? Random user surveys, and you would write, what you think, you will write 50 different lines for that. So if you are not writing, then oh, I'm good at writing utility classes, but that doesn't work, right? That's not my style. @inject is what you need. What does @inject do? @inject, as I said earlier, it comes from JSR 330, and instead of telling Dagger that I want this object, like previously we were writing those lines, these lines, means you are requesting from a component that I need these objects, and you will be initializing those references manually. So what I did was I used inject and random user service instances, and let Dagger react upon it. So you need to modify some code when you want to use inject. In main activity component, I have made changes. Like right now I just have void method, like method with returning void. So what will happen when a component is returning void? This is where Dagger reacts. Dagger when it comes to this point, and I have written @inject over here. So what happens behind the hood? When Dagger sees any method with void return type in a component, it checks its arguments. And what we have passed in argument? Main activity. So it searches in main activity that is there any field available with @inject. Yes, we have. So it will be initializing that. Simple. It is as simple as that, and we are done with the code. So still we can improve it with construction injection. We haven't used it yet. We have used field injection, right? We have using like we have injected in fields. We have not yet injected in constructors. So how we can do that? Main activity is passed as constructor with like our old implementation. So what I do is, we make an activity injectable. We'll be injecting an activity. How? We create an activity module, and then we write those methods that will be providing main activity. We have provides, we have main activity scope, and all that. In random user adapter, I made a little change. My random user adapter was requiring context earlier. Now I have replaced it with main activity, and I have written simple and @inject annotation over here. So as you know, @inject will inject that dependency over here. You don't need to write any code for that. And again, hitting Gradle build, mission is accomplished. So did you find Dagger easy? No, I mean, I'm asking seriously that how did you find Dagger now? Is it easy? Yes? You need workout. Definitely. Here it's look easy, but when you try to implement that, you will face many challenges. And I'm not telling that I am so smart that I just learn in just one night, but it is really easy. And if you want my slides to refer, you can definitely have it. And I have posted one demo also for GitHub. This is the same demo, and that's all with Dagger. Any queries? Yes. Yes.
My question is regarding the reflection. As
Yes.
In a slide that there is a mention that metadata are accessed at runtime.
Yes.
So is it a part of the reflection process, or is it internally?
No,
access?
actually Dagger 1 use those annotations to access at runtime. But what Dagger 2 is doing, Dagger 2, when you write this code, Dagger 2 actually will be replacing your current code with the code it has generated for you, and it will be compiling with normal process. So there is no runtime behavior with Dagger 2.
But with the Dagger 1 we can do it with runtime. Is it?
Sorry, I didn't get you.
That metadata are accessed at runtime. Is it possible with the Dagger 1?
Yes, Dagger 1 was actually doing that. It was accessing those metadata at runtime, and which was resulting in performance overhead. And that's why Dagger 2 improved that. It brought that to a step back, and it resolved those dependencies at compile time. So you don't have any chance of performance overheads.
Okay.
Any other questions?
इंग्लिश नहीं, मतलब प्रॉबेबली ORM जैसे कि रूम होता है तो वो पर्टिकुलर रीजनिंग देता है कि ये एरर है और आपको रिजॉल्व करनी है, बट डैगर के साथ वो पॉसिबल नहीं है. प्लस आपको ग्रेडल कंसोल में भी जाना पड़ता है बार बार कि कहाँ से वो डिपेंडेंसी मतलब
in not Gradle console actually. Yeah, I agree at one point that error, when you face any error with Dagger 2, but it actually says that some dependencies are unresolved. It says that at compile time itself, it won't even let you run your program.
But the stack trace is very large when you have multiple dependencies.
See, I also face this, and I just don't sleep that night that why I am getting such long traces. But when you read those places clearly, you will come to know that you are remaining with some includes attribute, or very small mistake you will be facing that, but it will be resolved as and when you get your hands on with modules, creating modules and all. So somewhere you will be forgetting something to put, some annotation or something, and when you get your hands on with those things, you will never face such issues with that. At beginner you are starting with Dagger, right? I mean,
yeah.
You are learning with, so definitely you will face this, but learn from that yes, I need to put that annotation and I need to include those dependencies and all.
Okay. And second question is, at the runtime when we define that application component initialized by these, and it finds the inject attribute in
right.
So actually that part is reflection, right?
No, this is what I said. There is no runtime behavior with Dagger 2.
Yeah.
It is actually all the dependencies are resolved in compile time. When you hit Gradle, it will build some classes in background Do you know the annotation
Data binding.
processes how work?
Like data binding.
Not data binding typically, but once you know the annotation processes how they work, you will be understanding how I mean your question will be clear with that. Actually, I don't have the diagram over here, so that I could show you.
So you are saying that those intermediate classes that generate
Yes.
that part.
Yes.
Okay.
So those generated classes, they will be replaced with your current code. No, I mean your current code will be replaced with those generated classes. So it, for us it shows like it's a runtime behavior, but it actually not a runtime.